we're going to approach vectors almost from the perspective of parametric equations. So rather than having parametric equations as two different functions, x equals something and y equals something, we're basically just going to write those two equations as an ordered pair, but it's an ordered pair of functions, and we call that a vector. So some terminology you'll need to know about vectors and what these things mean. So a vector is an ordered pair written in component form. So component form means that it has two components. It has a horizontal component and a vertical component in this case. It could be other components, but those are the directional components that we're going to use here. We use these, typically we use brackets rather than parentheses for vectors, although parentheses are typically accepted as well. It gets confusing when you use parentheses sometimes because there's no way to distinguish it from just a regular ordered pair then. So the A and the B there, those are the components. The A, like I said, is the horizontal component or the X component. The B is the Y component. And so far, this just kind of looks like an ordered pair, right? The difference between an ordered pair and a vector is that the vector is not this point right here at the head of the arrow, but it's the arrow itself. So this right here is the vector itself. So the vector has a couple of things. First of all, it is an ordered pair. It has an X component and a Y component. So we know that its size. So it has what we call a magnitude, and we'll talk about how we measure the magnitude. But the magnitude is just going to be the length of that arrow. And then it also has a direction. So this direction, if you wanted to describe it using words, you might say it's pointing up and to the right. But it has a direction, and we can quantify that direction in different ways. We can quantify it by measuring an angle with that and one of the axes. We can quantify it with another vector called a direction vector, and we'll talk about how we will do that as we get to those things. It might be kind of hard to see here, but some terminology that we're going to use with vectors. First of all, I took the coordinate plane away. There's a myth or a common misconception about vectors that they always have to have their tail at the origin or their starting point at the origin, and that's not true. The tail point can be anywhere. So a vector can start anywhere and then go in any direction. So the head is the direction it's going, and the tail is where it's starting from. So this is our origin point, and this is our terminal point as far as the vector is concerned. And then to find the coordinates of the vector, the components of the vector, we can do what's called a head minus tail rule. And you take the X component and the Y component from the head and subtract the X component and the Y component for the Y to figure out what the A and the B are going to be. One way that we measure a vector, this is one of the more important ways that we can measure a vector, is the magnitude. The magnitude is just the length of the vector. And a couple of things about this. First of all, to show the magnitude of a vector, we put it in absolute values. So these absolute values just mean the length or the magnitude of the vector. And what is this equation right here? It's the Pythagorean theorem or the distance formula, right? In fact, if you go back to the head minus tails rule, the A was x2 minus x1, and B was y2 minus y1. So this is the distance formula. It's the square root of x2 minus x1 squared plus y2 minus y1 squared. So this is the distance formula. So the magnitude of a vector is just the length of the vector, the distance between the head and the tail. We know how to do that already, right? Okay, one last thing. The direction angle of a vector. We can use trigonometry to figure out what the angle is. We measure the direction angle the same way that a ray is measured in the coordinate plane, meaning that we do it relative to the positive x-axis. So we would measure the direction angle of a vector by measuring this angle theta right here. If we had a vector, just going to draw one freehanded here. Let's say we have a vector right here. The way we would measure that is by measuring this angle right here. Okay. A vector has terminal angles just like any ray in the coordinate plane does, and you can find the measure of the terminal angle by measuring the distance, or I'm sorry, the angle between the vector and either the positive or the negative, but we would measure the vector itself, the direction angle, by measuring this right here. So just a quick reminder, in terms of trigonometry, this is going to be useful when we're trying to measure the angle. What is the sine of theta going to be in terms of A, B, and the magnitude of the vector V? Okay, so sine of theta is going to be B over what? The magnitude of V, right? And notice also that the vector V is written with what kind of font? It's bold, right? V stands for vector, not variable, but it's bold. So when we're writing a vector, at least on a computer, we'll use a bold typeface. If we can't use a bold typeface and we want to be sure that we distinguish it as a vector, we can put a little arrow above it, and that will tell us that it is a vector. So that would be the way you can do it by hand. You don't have to do that, but it's one way to show that it is a vector. Cosine of theta is going to be what? A over the magnitude of the vector V. And then the tangent of theta is going to be B over A. Just looking at these three relationships, which one do you think is going to be the most useful to us? Tangent, because all it needs is the components of the vector. It just needs A and B. We don't need to know the magnitude. We will have to be able to recognize when B and A are negative, and then therefore when tangent is going to be, what's going to happen with tangent, and so knowing what quadrant the angle is going to be in and stuff like that. So you're going to have to go back to your knowledge of trigonometry for those things.